All right, good day, everyone. You are welcome to our channel. Today we'll be looking at how to calculate distances on in nautical miles and also speed in knots. All right, so I believe some of us are familiar with these terminologies, especially is obtainable in the naval field. They are not big deals at all. So when we talked about nautical mile, we are simply saying is an angle of 1 minute that is subtended at the center of the earth compared to the O360. And when we measure it along the earth surface, we see that we're able to see a meter, meters that is different from the normal meter we used to know. All right, so when this is done, it was proven and discovered that 1 nautical miles is 1,852 meters, which is the same thing as 1.852 kilometers. And also 1 nautical mile is approximately 1.1503 miles. You see, it's a little bit higher than the miles we used to know. And also to say this, that this terminology is used in the naval field when you hear them saying knot. So what are they simply saying? They are actually talking about the speed at which a ship is moving or a boat, depending. For example, we have that one, the fact is being stated that a speed of 1 nautical mile per hour is equals to 1 knot. So 1 knot is actually equals to 1 nautical mile per hour. All right. Another thing we should know that if maybe you just overheard some of these naval people saying 100 knots, what does that mean? It simply means 100 nautical miles per hour, and this is equivalent to 185.2 kilometer per hour. Of course, by multiplying it by the conversion ratio. So basically, what we need to know is the conversion ratio. So basically, what we have here is conversion. It's just a matter of conversion. All our other examples remain the same. So all we just need to know is how to convert our answer to either nautical miles and our speed to knots, depending on what the examiner wants us to do. All right, so let's just look at a question very quickly to get down to this. All right, so look at this particular question. What I want to draw our attention to is that the examiner said they want us to have our answer in nautical miles. Okay, want us to have our answer in nautical miles and also our speed in knots. So let's quickly get down to this and start solving. So let's quickly calculate the normal way we used to do our calculation of speed. Then we now convert our answer to nautical miles and our speed to knots respectively. All right, so from the 2 points I'm seeing here, point A and B, I can see the same latitudes that is common to them. So and it's towards the northern hemisphere. So if I draw my latitude of 40 degrees north, okay, and of course I'm also able to see, okay, I'm able to see, okay, this is the center. I'm also able to see 28 degrees to the east. That's for me to get my point A. Of course, I have to draw my prime meridian. I'm sorry about that. I have to draw my prime meridian. So this is my prime meridian of 0 degrees as assumed. That's that. And then I have to take 28 degrees towards the east. I have to take 28 degrees towards the east. All right. So let's say this is my 28 degrees. So this point of intersection is my A. This is 28 degrees towards the east. All right. Then again, I also have point B, which is 25 degrees towards the west. Okay, I have this. Okay, this is my 25 degrees towards the west side. All right, so I have this point of intersection also to give me my B. All right, so what do I do now? I join all the 3 points to the center of this small circle. All right, then the question gave us another point C, which is 15 degrees towards the southern hemisphere. Okay, I have 15 degrees south. Okay, and I can see 25 degree west, which is the same thing with the 25 degree west that we have here. So this is the point of intersection. So this is point C. All right, so we can see clearly, of course, we have to draw our equator because I've drawn 2 latitudes. Of course, I must have a reference line So from the center, I have B. I have this point with the equator. This is their common longitude. So of course, all great circle must have their radius at the center of the circle. So it's always like that. So just like we discussed earlier. Okay, so this is how we are having. So we are seeing that very clearly from the picture that the distance from A to B is along the small circle. Okay, while the distance from B to C is along this great circle, this meridian. So we see that the formula we are going to use to calculate the distances is not going to be the same. It's not going to be the same. So because one is along a small circle, another one is along the base circle. All right. So very quickly, what do we do? The first thing to do is to calculate the distance from A to B. Distance from A to B, which is along small circle, it's going to be theta over 360 times 2 pi r. Okay, where this r is r cos lat. All right, so very quickly, let's get our theta difference. Our theta difference, which is the difference in longitude between point A and B, is 28 degrees east and 25 degrees west. All right, they have different directions, so we are going to add. So when you add 28 to 25, we are going to have 3 and 5. So 53 degrees is our theta difference. All right. So when this is done, we simply just insert it into the formula. So distance will now become 53 divided by 360 multiplied by 2 multiplied by 3.142 as given in the question. Then multiplied by 6400. Then multiplied by the cos of their common latitude, which is 40 degrees. All right. So let's quickly let me put on my calculator and let's punch this. Cos of my 40, cos 40 is this. That's 0.7660. Okay, let me quickly get that down. 0.7660 is the value. All right. So let's now multiply. So I have 53 divided by 360 times 2 times 3.142 times 6400 multiplied by 0.7660. Okay, when we do that, we are going to have 4535. So the distance is going to be 4535 point. There is a decimal. Let's just take it to 2 decimal places, which is 43. All right, so 43 kilometers. All right, so this is what we have for distance A to B. So let's now do distance B to C. Distance B to C is going to give us theta again over 360 because it's along the great circle. So it's just going to be this. So we have to find our latitude difference. Latitude difference is going to be the differences between the latitude of C and that of B. Okay, you can see that they have the common longitude, but their latitude is B is 40 degrees north and for C is 15 degrees south. All right, so they have different directions, so we are going to add them. So we have 15 added to 40. Of course, that's going to be 55 degrees. All right, so without wasting time, let's quickly just do this. So we have theta is equals to 55 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 6400. Okay, so if we punch this on our calculator now, we are going to have 55 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 6400. All right, when this is done, we have 6144. So the distance is 6144 point. Let's just accommodate the decimal, which is 36 to 2 decimal places, 36 kilometers. All right, so this is the total distance, the distance between B and C. All right, so what do we do next is to add up the two the distances between the 3 points. All right, from A to B added to B to C. So when we do that, we are going to have on our calculator now this distance plus the former one we had, which is 4535.43. Okay, that is 10,679. So the total distance that we now have is 10,679. Let's accommodate few decimals. 679 point, let's say 79. All right. So 79 kilometers. So this is what we have as our distance. All right. So what do we do next? We quickly just convert this distance to what we call the nautical mile. All right. So what are we saying in essence? So what we need to do simply is to bring the distance, the total distance that we have, which is 10,679.79 kilometers. All right. So, but we know that 1 nautical mile, from our previous explanation, 1 nautical mile is equals to 1.852 kilometers. So what is now going to be 10,679.79 kilometers. So let's assume it's x. So we are going to have 1 over x is now equal to, this is a proportion thing. I believe we know proportion. So we just do this. Some will not even do this. Some already know what to do. They will just divide straight. But you want to assume it's not everybody that understands this. So this is 1 over, I normally do it, this is a fraction, 1 over x, and on this side is 1.852 over 10,679.92. All right, so then you cross multiply. X will multiply this, then this. So when you do this properly, you are going to have 10,679.79 divided by 1.852. All right, so when we do this, let's quickly use our calculator to punch this. All right, so this answer divided by 1.852. Okay, when we do that, we are having 5766. So we have 5766. There's a decimal there, which is a 62. All right, 62. So this is going to be in nautical miles. All right, so this is what the examiner actually wants us to do. After getting your normal distance, then you just use this conversion ratio and take it to the nautical miles. All right, so the second question simply just say we should find the speed. How do we find the speed? Speed is just distance divided by time. Okay, that's distance divided by time. Okay, so what do we do? Our distance already, so speed is going to give us 10,679 points this divided by, they give us the time is 20 hours. Okay, so when you use 20 hours to divide it, 20, what do we get? Sorry, let me quickly pick up my pen. So this is 20. All right, so let's quickly just do this. We are having 10 0, that's 10679.79 divided by 20. Okay, that is 53398, or let's say 99. So we have 533.99 kilometer per hour. Okay, now instead of using this, why not we can just use the nautical miles direct, because we know that 1 nautical miles per hour is equals to 1 knot. So I think it's better, instead of converting this, using this for speed, we rather use the one in nautical miles, which is 5766.62 divided by 20. So when you do this, you are going to have what it takes to get the answer. Okay, so let's just do 5766.62 divided by 20. Okay, and this is going to give us 288. So this is going to be 288. All right, so this is 2888 nautical miles per hour. Okay, and we know that 1 nautical miles per hour is equals to 1 knot, so which is approximately 288 knots. Okay, so I believe we enjoyed this video. Thanks for watching, and I see you in another video where we'll be talking about how to calculate shortest distance on the Earth's surface. Thank you for watching. Please like, subscribe. See you in our next video. Thank you.